Hey guys, how are you? Welcome back to the channel. Today is day 23 of upskilling myself, and today I solved 3 DSA problems and I had some internship work to do. So, yeah, let's see the DSA problems that I solved. So, first problem was happy number. So, if a number is 19, then we have to show whether it's happy or not. So, what is happy number? So, happy number is, let's take an example of 19. So, we have to square both of the digits and sum them. Okay, so 1 square is 1 plus 9 square is 81. So, 1 plus 81 is what? 82. Then same for 82. What we have to do is we have to square 8. So it's 64 plus 4, which comes out to be 68. Right. Then same for this. 6 6 are 36 plus 8 8 is 64, which comes out to be 100. And for 100, as you know, 1 square is 1 and 0 square is 0. So it would give us 1. So if a number gives 1 after adding the square of its digits, then it's a happy number, right? So to solve it, what we did was we created this simple function over here which gets the digits and squares it and adds it to the sum, right? Then we create two pointers, which is the slow and fast. The slow is initialized on this number, and that is 19, and the fast is initialized to the next iteration of it. So slow is over here on the 19, and the fast is on 82. Then, well, fast is not equals to 1 and slow is not equals to fast. Slow is advanced by 1 and fast is advanced by two functions, right? Two operations. And if fast is equals to slow, then we return false, and if fast is equals to 1, then we return true. So why we are using this logic? So as you can see over here, there is no loop forming, right? No number is repeated. 68 is not equals to 100, 100 is not equals to 82, is not equals to 19, right? So in this case, we will get fast is equals to 1. But let's say a case where we don't get 1, instead we get 19 again. So we fall in a loop, right? So in a loop, sometimes it will happen that fast will be equals to slow, and when fast will equals to slow, then it will not return 1 and it will return false. So the next problem was longest consecutive sequence. So we have been given an array and we have to find the longest consecutive sequence. So over here, it's 100, 4, 200, 1, 3, and 2. So as you know, if we remove this 100 and 200 over here, we see a sequence of these numbers, right? So how do we identify that we have to remove these two only and not remove this 4? So what to do is we use set to store the numbers. As you know, that set does not allow storage of duplicate numbers. So we create a set, then we create int max length to store the maximum length, then we create current num and current length, and then we traverse the array. And now if suppose we are on 4, right, and suppose if 4 is not in the set, then we set the number in the current num, then we set the length as 1, and while we don't get interrupted by any other number which is not in the sequence, we traverse, right? So we increment the current num and we increment the current length, and when we are interrupted, we calculate the max length, which is the maximum of the max length and the current length. Okay, and after all, we return the maximum length. So the next problem was split array into consecutive subsequences. So if we are given an array, let's say this, then we have to split it into subsequences of size at least 3, and maximum it can go like infinity. So how to solve it? So to solve it, we used two hash maps, one to store the numbers and other to store the need. So let's say we formed this type of subsequence, right? So the next number the subsequence will need is 4. So this next number we will add into the need hash map, right? And this hash map will have all the numbers. Okay. So first of all, we create an unordered map, which is frequency and need. Then we add the elements in the frequency map. So this frequency map will be initialized with all the numbers of the array, and this will be empty at first. Then we traverse the array, and then if the frequency of num is equals to 0, then we continue, right? Now comes three conditions. So the first condition is if num is needed. Okay. So as you can see over here, 4 is in the needed map, right? So in this case, we have to remove 4 from that map and insert 5. Why? Now 4 will be the subsequence, and then the need will be for 5, right? Now else if the num starts the subsequence. So if the frequency of num plus 1 is greater than 0 and the frequency of num plus 2 is also greater than 0, which means if the next two elements of the subsequence are not equals to 0, then we add it into the subsequence, right? So we reduce the frequency of the next two elements and add the need for the third element in the need map, right? Else if neither of these two conditions satisfy, then we return false, because we don't have to fulfill the need array, as well as this is not fulfilling our condition, then we have to return false, right? And after every iteration we have to reduce the frequency of the num, and then we return true if this loop is exited without returning false. So for the development part, I did some internship work. I had to migrate the complete front end, as I told you in the earlier videos. So yeah, it's taking a bit of time, and I did the revision of all the DSA problems that I solved till now. So yeah, that was it for day 23. See you on day 24.